So for number 3, again we are going to go ahead and graph without the use of a calculator. So notice for this one again, we don't have to do any of the domain range or any of that information. So we're going to go ahead and just find our point discontinuity, that's where I usually start, and then go to our vertical asymptote, our horizontal asymptote, our x-intercepts, our y-intercepts, and then finally if there is a slant asymptote. Okay? Alright, so first off, let's start by factoring. So when I factor, I'm looking for two numbers that when I multiply I get 3, and when I add I get negative 4. Those two numbers in this case are x minus 3 and x minus 1. On the bottom, I'm looking for two numbers that when I multiply I get negative 6, and when I add I get negative 1. And those two numbers are x minus 3 and x plus 2. Now if you notice, I have a common factor on the top and bottom. So that is going to be my point discontinuity. So I'm going to go ahead and cross those out, and therefore my point discontinuity is when x is 3. Now in order to find the y, I'm going to go ahead and finish simplifying this function, and that's where I'm going to plug that 3 into. So it'll be 3 minus 1, which is 2, and 3 plus 2, which is 5. So my point of discontinuity is going to be at 2/5. And I'm going to go ahead now and fill in my point discontinuity, which happens to be in about the same place as before. Alright, now, for my vertical asymptotes are when my simplified function equals 0, or when the bottom of the simplified function equals 0. So in this case, x plus 2, it's going to equal 0 at negative 2. So x equals negative 2 is going to be my vertical asymptote. So I'm going to go ahead and fill that in to my graph. Alright, so now I am going to find my horizontal asymptote, and I'm going to look and see that both x squared and x squared, it's equal, which means I use the coefficients of those, which are 1 and 1. So my horizontal asymptote is y equals 1 over 1, or y equals just 1. So again, I'm going to go ahead now and fill that in my graph. Remove that. Alright, so since they were equal, I know that I have no slant asymptote, so I can go ahead and fill that in as well. Now for my x-intercept, that's when y is 0, which basically gets rid of the bottom, and I just look for x minus 1 equals 0, so my x-intercept is actually going to be at positive 1. My y-intercept is when x is 0. So 0 minus 1 is negative 1, 0 plus 2 is 2, so my y-intercept is negative 1/2. So now I'm going to go ahead and fill in my x-intercept of 1, and I'm going to fill in my y-intercept of negative 1/2. So there's where my two x and y-intercepts are going to be. Alright, so from here, I didn't have to do synthetic division. If you want to write your vertical asymptote as limits, you can do that. But let's do that after we go ahead and sketch our graph. And to sketch the graph, remember you want to do a sign analysis, and you use your vertical asymptotes and your x-intercepts. So we're going to be between negative 2 and 1. Now if I do a sign analysis of something to the left, let's pick negative 10, because that's just an extreme value that's easy to see. So negative 10 minus 1 is going to be negative. Negative 10 plus 2 is going to be negative. A negative over a negative is a positive. Between negative 2 and 1, 0 is an easy one. 0 minus 1 and 0 plus 2, that's going to basically be a negative value. And then, after 1, let's pick a big value like 10. 10 minus 1 is positive. 10 plus 2 is positive. Positive over positive is a positive. So now, you know that this is going to be positive up here. Easiest way you can tell is you have the two vertical and horizontal asymptotes, and it's going to be a curved function, a smooth curve looking something like that. Over on this side, you have a lot of points to guide you. This is going to approach the asymptote, and then it's going to go down and then approach the other vertical asymptote. So now it's going to be pretty easy to do your limit statements. So you have negative 2 from the right and negative 2 from the left. So from the right, if I approach negative 2, here's negative 2. If I approach it from the right, it's going to go down to infinity, negative infinity. If I approach it from the left, it's going to go up to positive infinity. So there's your limit statements. Okay, and I think that about does it.